This video is brought to you by mywayteaching.com.
So now let us solve a very simple problem. A bullet of mass 0.04 kg is moving with a speed of 90 meter per second, and it enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? So you just consider this. This is a bullet. The mass of the bullet is given by 0.04 kg, and it is moving with a speed of 90 meter per second, which means the initial velocity is given by 90 meter per second, and it enters a heavy wooden block. You just consider this wooden block. Okay, it enters a heavy wooden block. So it is entering this wooden block, and it travels a distance of 60 centimeter, and then it stops. So now we need to find the resistive force which is exerted by this wooden block on the bullet. So now, before finding the resistive force, we need to find the acceleration, because the product of mass and acceleration gives the resistive force F, isn't it? According to second law. We know that the laws equations of motions, we know u square plus 2as is equal to 0. From this we get the value of a as minus u square by 2s, isn't it? So we know the initial velocity is given by 90 meter per second, and the distance is s. So here it is given in terms of centimeter. Since the unit is meter, we should convert it in terms of meter, that is given by 60 into 10 raised to minus 2 meter. So we can write it as 0.6 meter. Okay. So after simplifying this, we get the value as minus 6750 meter per second square. This is the retardation A. Okay. Now we need to find the retarding force. Okay, the retarding force according to the second law of motion, F is equal to m into A, and we know the mass of the bullet is 0.04 kg, and the retardation just now we found, that is 6750 meter per second square. So if you multiply these two, we get the result as 270 Newton. So this is the resistive force. Okay, what is this? Resistive force which is exerted by the wooden block on the bullet. So this is the average resistive force, because the actual resistive force or the retardation of the bullet may not be uniform. So the answer therefore only indicates the average resistive force. So now let us see one more simple problem. So now let us consider one more very simple example here. The motion of a particle of mass m is described by y is equal to ut plus half gt square. Find the force acting on the particle. We already know that the second law holds good even for a particle and for a system of particles. Means we can apply second law of motion not only for a particle, even for a system of particles. So now we need to find the force which is acting on the particle, and the Motion of that particle is described by the equation y is equal to ut plus half gt square. Okay, and now we know that the final velocity, okay, the final velocity v is equal to is nothing but dy by dt, isn't it? The motion of the particle is y. So dy by dt gives the velocity. So if you differentiate this equation, we get u into t. The differentiation of ut, the const, it is u. Okay, where t is a variable here. Plus half gt square. So here the differentiation is 1 by 2 g, and t square will become 2t, isn't it? And these two and this two get cancels, and we'll get u plus gt. So this is the velocity equation. So we already know that the force F is equal to ma. In this particular case, the acceleration is nothing but acceleration due to gravity. So that is m into g. So thus the given equation describes the motion of the particle under acceleration due to gravity, and y is the position coordinate in the direction of g. Okay, y is the position coordinate in the direction of g, and this is the equation for the particle or the motion of a particle under the acceleration due to gravity. Okay, now let us study one of the important topic under this, that is called as impulse. What is this impulse? See, we sometimes encounter examples where a large force acts for a very short duration, producing a finite change in momentum of the body. So, large force, but it acts for a very short duration of time. For example, when a ball hits a wall and it bounces back, the force on the ball by the wall acts for a very short time when the two are in contact. Yet the force is large enough to reverse the momentum of the ball, isn't it? Even though the force by the wall on that ball is for a very short duration of time, the force is very much greater that it reverses the momentum. Often in these situations, the force and time duration are difficult to ascertain separately. However, the product of force and time, which is nothing but the change in momentum of the body, remains a measurable quantity. Measuring the force and time separately is quite difficult, but the product of force and time duration, that is nothing but change in momentum, is a measurable quantity, and that product is called as impulse. Okay, you're getting the right. The product of force and time duration, that is nothing but change in momentum, this is a measurable quantity, and this product is called as impulse. A large force acting for a short time to produce a finite change in momentum is called as impulsive force. Okay, a large force which is acting for a short time. Okay, a large force acting for a short time to produce a finite change in momentum is called as impulsive force. Okay. In the history of science, impulsive forces were put in a conceptually different category from ordinary forces. Newton mechanics has no such distinction. Impulsive force is like any other force except that it is a large and it acts for a short duration of time. So let us solve one more very simple problem. So the next simple problem, a batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. So here also the force which is acting is an impulsive force because the ball, when a bowler hits the ball, when a batsman hits the ball, it is for a very short duration of time, isn't it? But still the force is very much greater that it reverses the momentum. So in this particular case we need to find that impulse. Okay, that is nothing but change in momentum. Assume linear motion of the ball. That is the condition given. So we know that the change in momentum or the impulsive force is given by force into time duration. So in this they have given the initial speed, that is u, we can say the initial speed 12 meter per second, and the mass also they have given, that is 0.15 kg, isn't it? Yes. So the change in momentum is given by 0.15 into 12 minus of minus 0.15 into 12. Okay, that is according to second law, which is given by 3.6 Newton second. So we can write impulse as 3.6 Newton second in the direction from the batsman to the bowler. In the direction from the batsman to the bowler. So this is an example where the force on the ball by the batsman and the time of contact of the ball and the bat are difficult to know, but the impulse is readily calculated.